All right, so today we're going to talk about some of the other factors that shape ecosystems, and those are really the factors of the individuals themselves. Um, so we've talked before about the concept of a habitat, which is pretty much wherever you will find an organism. So, for instance, or a species, I should say. So the blue area is anywhere you're going to find black bears. All right, the blue area here is anywhere you're going to find grizzly bears, and here is anywhere you'll find wolves, and then here is anywhere you'll find deer. So what that basically means is that if you were to go anywhere in that blue area, it's possible, uh, you know, possible to see any one of those particular species if you were to be in any of their respective blue areas. All right. So what we're going to focus more so on something that's a little more complex, which is called its niche. All right, so it's not only where it lives, but it's other factors, like for instance, the physical factors that it's abiotic physical factors, like the amount of water it needs, where it needs to sleep at night, if it makes a nest, what kind of materials it makes its nest from, the nutrients that exist in the level in the ecosystem, for instance. And then the biological biotic factors would be primarily the food it eats, the other animals or the plants that it eats, or its needs to mate or something thereof. So there's a lot of factors that play into an organism's niche. Because of these needs and the needs of all the different species in the ecosystem, what's going to happen is you're going to start to see relationships forming between different species. So, for instance, if I were to look at the black bear and the grizzly bear, they coexist where there's some overlap here. Now, they're not hunting one another, but they are competitors. They might be competing for the same food. Or same thing with the wolves. The wolves and the grizzly bears coexist in a similar area here. So where they coexist, same thing. They're probably competing for food. Now, turn that around here, and if we look at it from the deer's perspective, in that slight overlap there, that's a bad place to be a deer, at least as far as the eyes of the grizzly bear are concerned, because that's where the deer is being hunted by the grizzly bear. So some relationships we've seen, one in which, like I said, is competition. So that's when different species share similar resources. So, for instance, the two types of bears and the wolves compete for food, which would be the deer in this case. Um, but the truth is that two species cannot share the exact same niche. All right. So in other words, if they're eating the same thing and living in the same area and using the same water source and everything thereof, um, something's going to happen. So what usually happens is one will either migrate away and find a new habitat to occupy a niche. Sometimes one just dies off; it's just overcompeted, or sometimes they'll live and they'll coexist, but it will occupy a new niche. It might actually hunt a different animal, or it might find a different type of shelter than it may not be accustomed to. All right, so there's a little picture of just within a tree, you have three different species of birds who, albeit they're sharing the same tree, what they do is they kind of adapt to the different parts of the tree. And they adapt by the type of food that they probably eat, by the type of nest that they're going to create, among other things. So it's almost as if they're creating three little niches within a tree. All right, and I mentioned this as well as the classic predator-prey relationship that exists. So in this case, the poor deer is the prey to the three different types of predators when they coexist. All right, so in this picture here, and again, this is why it's important to look at these food webs, because there's so many different things you can look at it. What if I ask you guys what relationship exists between the rabbit and the fox? All right, and that example was a predator-prey relationship. What type of relationship exists between the hawk and the owl? Well, because they both eat the same food, they're both competitors. All right, they're competitors with one another. What about the raspberry bush and the sparrow? And that is also a predator-prey relationship. Prey doesn't have to be an animal. I mean, if the sparrow is eating raspberries, that is its prey, and the sparrow is the predator to the raspberry bush. What about the fox and the mountain lion? So that is a predator-prey relationship because the mountain lion does eat the fox, but it's also a competitor. So these things don't have to be clearly one or the other. They can be both. Because both the mountain lion and the fox both eat the rabbit, they are also competitors. All right, so some relationships that can exist are what are called symbiotic relationships, and this is when two different species live closely together. There are three types. One of them is called mutualism, and that's when both species benefit from the relationship, and this is the best of, by all accounts, to be a part of. So I'm just going to use little emojis here. So, albeit this looks like a bad place to be for that bird, but believe it or not, what's happening is that crocodile is opening its mouth, welcoming the bird, and the bird is picking out little stranded bits of flesh in the teeth of the alligator, and that's good for the bird. That's food for the bird. And that's actually good for the alligator too, because it's almost as if the bird is cleaning the teeth of the alligator, and likewise um, preventing him or her from having infection later. So that is a mutualistic relationship, and then the crocodile does not suddenly turn on the bird. The birds will learn very quickly to stay away from them. So this is a symbiotic relationship where the bird benefits the crocodile by cleaning its teeth, and the crocodile benefits the bird by providing food and probably a safe place to be. There's probably aren't too many predators that want to hunt that bird right now. And then this is the classic sea anemone, so, as you see in perhaps your favorite movie, Nemo. So the anemone is actually poison. Is yeah, it'll sting. All right, but believe it or not, the clownfish has evolved that it does not get stung by the sea anemone. So it swims within the tentacles of the sea anemone, picking off flesh, and likewise preventing it from parasites and such, cleaning it from parasites. But just the same, the sea anemone, because it does sting, protects the clownfish from its predators. The predators are far less likely to hunt the clownfish if it's swimming through the tentacles of a sea anemone at a time. So sea anemone gets cleaned of parasites, and the clownfish gets shelter from predators. All right, now the next one is kind of like an in-between. So it's commensalism. So the thing is, somebody always has to benefit. All right, if nobody's benefiting from a relationship, there's no sense that it's going to exist. So one person is going to benefit, but the other one is not hurt, nor are they being affected. All right, so they're not benefited, they're not hurt. Their life would be just the same if the beneficiary was there or not. So classic example is the shark and the remora. It's a type of fish, if you will. So what happens is the shark swims around, and this smaller fish swims underneath it. And if you've ever seen sharks eat, it's not a very pleasant experience, and a lot of flesh tends to fall down to the ocean floor below it. And this type of fish will just kind of pick off those little bits of flesh. And just the same, the smaller fish is actually protected from its predators, because no predator is probably going to want to come by nearby a shark. Now the shark isn't benefiting whatsoever. All right, that food that it was scrapping anyways was just going to fall to the bottom of the ocean anyways. So whether that smaller fish is there or not, it doesn't affect the shark. But the smaller fish benefits because it's fed, and then likewise because it's protected from predators. And then this example too. So the cows naturally attract flies. So this bird, if you will, is hanging around just collecting flies. Not enough so that it's benefiting the cow by any stretch of the means. It's not like it's decreasing the fly population to the point where the cow is that much happier. But it's definitely benefiting because it's getting plenty of food. But the cow is not being affected whatsoever. And that's not a heavy bird by any stretch of the means to put any excess weight on the back of a cow. All right, now the grossest one, if I may say, is parasitism. And this is when one benefits and the other is harmed, not often killed, eventually maybe, but at least for the early time being, not killed. So a tick is a common example. So the tick is benefiting because it's getting nutrients, it's getting shelter, sometimes it's getting a place to hatch eggs. All right, but the host, in this case, perhaps a dog or something thereof, is definitely being hurt, possible risk of infection, losing nutrients to the tick and otherwise. And this is pretty gross. This is the cross-section of a intestine, and that is a tapeworm. Tapeworms start small, and they get inside of your small intestine, and they basically start to feed off the food that is passing through the small intestine. And when they feed off the food, that's less food that makes its way to the host. And they actually, not only that, it gets progressively worse because as they eat more, they get bigger, and as they get bigger, they eat more. It's this really horrible effect on the host, and eventually it can be deadly, but in the early stages at least, it just often leads to weight loss and poor health and otherwise. So basically, these different types of relationships keep an ecosystem stable as best be. Here's a little picture when I was a little kid. Basketball hoop my father had put up just prior to me being born. You know, slowly getting there. But this picture of me about 20 years later when I was sending my sister off to college, the hoop's gone, tore it down. You know what I'm saying? But if you notice, the background is changing a lot. A lot, the forest, if you will, the woods next to our house, were a lot more dense. So I'm using it as an example of a changing ecosystem. All right. So what we see in changing ecosystems is that they perform what's called ecological succession. All right, and these changes are much more rapid if inhabitants start to die out. So if there's some individuals in there that die off, or if outsiders move in, so you're bringing in new species, or abiotic factors are changing. For instance, there's more water or less water, more of a certain nutrient or less of a certain nutrient. And then obviously, if human activity is affecting it, that's going to change the rate at which an ecosystem is going to change. So this is a classic example. So this actually shows you the early forms of life. There's really not much life here. It's just basically barren rock. But you're starting to see some life form. And if we look at it, fast forward a few years later, you can actually see that life is almost taking back over the entire rock surface. All right, to the point where eventually albeit it's not a very lush ecosystem, but you actually have pretty much a layer of soil that exists over that rock. And to the point now where you actually start to see some grass and even some shrubs. So those first organisms that inhabit any ecosystem are called pioneer species, and they perform what's called primary succession, which basically means that they somehow are able to move into an ecosystem that has no life and be the first forms of life in an ecosystem. There's a cute little example here where there's a rock wall, and you have a little tree or a little plant of sort starting to grow out of a small crack on the wall, and allow more time with that life, more life will follow. All right, this is a relatively recent volcanic eruption, obviously cooled, but you have plants now starting to form on what is basically an uninhabited area. So that would be a pioneer species. So here's a classic example. So usually it's your annual plants, your plants that kind of they seed themselves, they grow, and then they die, and that's it. That kind of make their way into an ecosystem to start things off. All right. If you fast forward, then it becomes your perennial smaller plants, the plants that they'll grow and then they'll return every season. And then eventually you start to welcome in more complex plants like your shrubs and small trees and such. And then you actually make your way to the legitimate small trees like your soft pines and such. And then you actually have a true forest, which would be like much more complex trees. So this kind of shows you how an ecosystem can start from nothing and eventually become a much more complex, diverse ecosystem, starting with your annual plants and working your way up to much more complex plant matter. And leaving out the picture is the consumers. So once you bring in the producers, the consumers will follow. You'll start to get more insects. You'll start to maybe get some birds, some other types of reptiles and rodents and such. And eventually, with them, you can have much more complex, much more upper level carnivores that will follow in suit. All right, and then there's what's called secondary succession, and this is when a human activity has affected an area, or a natural event for that matter. So the classic example, like a volcanic eruption. So there was life, a volcanic eruption happens, and then life starts to form, to, if you will, make its way back into that ecosystem. Or in this case, an entire area is wiped out to put down a sidewalk, left unattended. Life will take it over. All right, life will slowly creep back over, growing and decomposing, creating soil, and eventually more life will follow. Last thing I want to talk about today are what are called invasive species. They cause massive ecological succession. What they are, they're any species that's not native to an ecosystem. So in other words, they're an outsider, they are sometimes called alien species. So the brown tree snake is an example. We'll probably watch a video in class about the brown tree snakes and how they were brought into the island of Guam, and then they literally just took over and changed the ecosystem for the worse. So the truth is that other organisms that are already in the ecosystem have not evolved with this invader. They don't recognize it as a predator or a competitor or anything thereof, and they just don't recognize it as being a nuisance whatsoever. Because of that, and then there are a few things that want to hunt it. So that's when I'm talking about it, I mean the invasive species. So it really doesn't have a predator, And because of that, it starts to overhunt its prey to the point where sometimes its prey is not even aware that it is a predator. And it creates this very unbalanced competition. It's almost not fair that the invasive species is basically not being hunted by anything, uh, begins to hunt other things, sometimes plants and or animal, and eventually can cause massive devastation in an ecosystem. So this is another classic example, especially around here. The gypsy moth caterpillar was brought here from outside, and basically there aren't too many things that, believe it or not, want to eat it. I find it hard to believe, but it feeds relentlessly on broadleaf matter, sometimes destroying and wiping out entire forests. There's this example too, the Asian longhorn beetle, that will burrow its way into trees to lay their larvae. Um, and there aren't too many things that want to hunt them, so they reproduce very quickly. And in doing so, they spread their larvae and likewise burrow a lot of holes and weaken and kill a lot of trees because of it. Um, so this is a particular nuisance that they're particularly worried about in central Massachusetts. At least they were a few years ago.